Hey guys, Nikos here and welcome back to another tutorial on D3.js. Not R this time, I remembered. So we've done this one last, now let's look at this one here. This one. So we're starting off with data like the other one. We're getting some div, some HTML, and we basically create the div, append the data, and set make it another bar chart. So it talks a little bit about how you can create a chart manually. Nobody would want to do that in their right mind. It goes on to talk about programmatically creating one. So in this case, they're taking each data point and multiplying it by 10 to get a value in pixels, and then drawing it on the page. And then they go on to talk about scaling issues. So at the moment, the way this code is that it's everything's like value times 10, you get this value in pixels, which isn't really flexible. So what it goes on to talk about is this sort of scaling function, which instead of using 10 times d equal pixels, you actually call this function here, and that allows it to scale better. So let's look at that code. So what I've done is I've took that code and mashed it up here. So yeah, let's see how that's running. Okay. Right, so we'll just pause the code here, and it's going to store this inside of X. And even though this is a function itself, it generates another function. So for example, I press like X like this, it's going to return as a function. And we're just going to run this, and we're going to pause it in here and apply this function to each value of X, and which is each one of the data points here, and see how it works. So if we just do X of D, let's see, we're going to get the value 40. 4 will be applied to the domain, and that will give us the sort of the percentage of 4 within the domain. So in this case, 4 out of a max of 42 is around 10%, and then that is applied to the whole range. So here is a difference of 420. So you take about 10%, and that will give us the value that we want to plot as the width here, right? So it's going to be about 40. And that is the value that we actually get in this case, right? So we can actually just play around with this domain function to see what we can get. So if we have a domain between 0 and 20, and we put in 10 as a parameter, that's going to be around 50% of the domain range. And then that's applied to the full range, which is going to give us a range of about 200, right? So that might look confusing at the first, but actually it's pretty cool and flexible, which allows you to scale things better. That's pretty much what's going on there. Right, so then they go on to part 2, which talks about SVGs and stuff like that. So whereas HTML is largely limited to rectangular shapes, SVG supports powerful drawing primitives like bezier, curves, gradients, cutting masks, etc. We won't need all this SVG extensive feature set for a bar chart, but learning it is worthwhile. Okay, and despite obvious differences, SVG and HTML share many similarities. You can write SVG market and embed it directly on a web page, and you can inspect SVL elements. Okay, yep, that's good. We know that. Right. So this is just looking at SVG. So here's a styling, and you can apply styles to SVGs, believe it or not. And what you do is you have this SVG tag, and then you have these transformations applied to the G element are performed on all of the child elements, and any of its attributes are inherited by child elements. I can also group multiple elements to be referenced later with the use element. Ah, I see. Very good. Okay, so going back to our example, what we've done here is we have a SVG graphic, and we have a rectangle here, and of a height of 19, and they all have this similar height and different widths, except that this one is translated between 20 of the y. So I wonder if we can actually change this in line. Let's just stick to 100 like that. Sort of, but for some reason the colour's not appeared. You need to give a greater height with the chart in order to see it within the bounds of the actual SVG graphic. Yeah, okay. Continuing on. So we apply stylisticity to it. A common point of confusion is in SVG is distinguishing between properties that can be specified as attributes and as styles. Okay. A quick rule of thumb is that geometry such as width of a rectangle must be specified as attributes, while aesthetics can be specified as styles. While you can use attributes for anything, I recommend you prefer styles for aesthetics. This ensures inline styles play nice with. Okay. SVG requires text to be placed within text elements. Okay, that makes sense. Yep, so there's a text element there. Coding a chart automatically. Now let's construct the chart using D3. By now parts of the code should look familiar. Alright, so in our case, since we're starting with instead of a div, we're starting with an SVG in this case. So let's look at what's going on here. So we have our data in the array, and we set the parameters here as variables, and we'll reuse them. So we've got our usual sort of scaling function going on here. And let's just look at the code quickly. So we have an SVG class chart. Right, so let's just step over that. So are we actually changing some of the attributes here? Let's just double check this. Okay, so we've actually changed the attributes with the code based on the height and the height and the width. So the height being 420 and the width being so we have some calculation here to set the height. And G, so this group or whatever it is, we don't have any elements specified at the moment, so let me just query what that's going to do. So select all G, right, so it's an empty array, okay, and its parent is the SVG, right, so then we're going to say that, right, so what this is going to do. So what did that do? So basically it's created the G's and it's created transforms for each of them. So basically we added a transform and we're returning a function based on what the translate value we want to be, and that's what this translate 0 and then the translate 0 and then there's the height there. Okay, so we have our groups, and then what we're going to do is we're going to actually append rectangles to each of the groups. There we go. Let's just check the code. So within the append, we're appending the rectangles to each G, and then we're also appending the text, and we have some functions to specify the exact position. So within the group, the height is relative to the current group, and I guess the X is depending on the actual width of the data here. So in the case for the text, or as D is the 4, for example, from our data here, the scaling factor is applied, so we're getting 40 out, and then we just want to shift the the actual text that's rendered minus 3 pixels in that direction. And the y, as obviously, is in the middle. And dy. So for the text, the only thing that actually renders the text is in the text here. The rest are all positional attributes. So let's see. So we're just returning d as a text. So that was the first one there. Second one, let's just check the elements so we know exactly what's going on. I just want to point out that this y and dy kind of almost do like the same thing, but what we're doing with the dy is we're specifying a specific em value with the this one set in pixels. So this helps us to be aligned in certain instances better than if it was just a y coordinate by itself. Okay, so let's just play this. So there we are, there's the 4, and let's just play them all. So let me just go into the elements here and talk about this dy a bit more. So if we go into our text element, we can see that it's there, and the 0.35 is making it look, I guess, better censored than it was just at half exactly or whatever. So if we just so we can adjust this. If we just move this and make it 5.5. Yeah, it's not aligned now. If we don't have any value for this dy, then it's going to be setting y equals 10. So this is an alignment kind of thing. So that covers the code for this section. Now let's just go to the next tutorial part. So in this next part of the tutorial, we're going to be loading data from a tab separated values file. You might have heard of comma separated value files, which is kind of more common, or known as CSV. But anyway, what we're going to do is we're going to load this data in, and there's going to be a callback, which is the function once the data is loaded. And D3 has its own libraries for loading files. And so basically, what says here, thus we need to separate the chart implementation to 2 phases. First, we initialize as much as we can when the page loads before the data is available. It's good to set the chart size when the page loads so that the page does not reflow after data downloads. Second, we complete the remainder of the chart inside of the callback function. So what we do is we have the loading function, and then within the loading function we're going to set our domain function based on the actual data that we return. So let's talk about this. So basically we're saying we declared the X scale in the same place as before, but we can't define domain until the data is loaded, right? So we're going to have this chart's going to scale based on the values. So that's what it's telling us there. This is basically how we would do the data if I wanted to do it inline within the JavaScript. So what it's saying is n in the place you now refer to d must refer to d.value because we're using TSV. So in particular, whereas before we could pass scale x to compute the width of the bar, we must specify a function that passes the data value to the scale. Likewise, when computing the maximum value from our data set, we must pass an accessor function d3max to tell us how to evaluate. And one more gotcha is types. The name column contains strings, while the value column contains numbers. Unfortunately, TSV isn't smart enough to detect this, so we have to specify a type function to basically parse out the correct number. So later on I'm going to talk about TypeScript to see if we can actually help with this kind of stuff. So let's run the example now and see if we can understand what's going on. Alright, so we have our breakpoints in here, and then we're going to load the data and pause and see if we can understand what's happening. So just refresh the page. Okay, so we've got some things that we want to specify for like the width and the heights here of the bars. Let's step over this. So we want to basically say that the width will be the range here the range of potential values that we want to apply to this chart. We know the width of the chart, but we're not sure of what the domain is just yet. So let's step over this. So we basically access the chart here, and let me just open up network here just so we can actually see what happens once data is loaded. So let's just step over the code. We should see a network loading request. Okay, let's just check the network. So basically we're loading the data locally here, and so we reduce a GET request to the files being hosted on my WebStorm local server, I guess. This would also work with just a local serving by a file system in Google Chrome or a browser of your choice. So response looks like that, separated by tabs. Hope that makes sense. And let's just inspect this data now. So let's look at what's going on here. So we have no error, but we have our data that's been parsed into an array. So here's the name and the value, etc., etc. Now, before we had for setting the domain, remember the domain is it's basically the values that we set the percentage of the range based on what the values are. So in this case, we're setting the maximum value of the domain basically, instead of being just equal to data, like in the previous example we had the domain as just DC, the max data, but we don't pass data in that. We also pass a function so that it knows how to find the exact value. So basically what it's doing is it return d.value to get the values in order for max to understand this. I hope you get that. So let's just, for example, we're stepping into this here, and d in this case will be a value of an object, and we just want to return the values, and that'll give us our domain. So for the actual height, we're setting the actual height of the chart dynamically before after the data is loaded. So we get the length and we times it by the bar height, and that will give us a value for the chart height in a sense. Yeah. So the height chart, let's go in here for example, and so let's just drill into the chart here, and if we go into the SVG node, we should see the height somewhere. So there we are, client height 120, which is 6 times the height of 20. Okay, 6 and 20. Now in this case we want to get the G elements, and we're going to append these G's with the correct offset. We're going to add our rectangles, remember, and we're also using d.value instead of just applying d in each time, and that should render as normal. So there we go. Great. So hopefully that makes sense how we can load data and set the height of the chart dynamically. So now let's go to part 3. This is a pretty good tutorial, so I like this tutorial. So in the previous parts of the tutorial we made a basic chart.